Hi and welcome back to our third video about our DevSecOps pipeline, which we are going to build with GitHub. In this video, we are going to look at SCA, which is the software composition analysis. In our past videos about the DevSecOps pipeline, which we are building with GitHub, we have introduced this pipeline, which we see up here. As you can see, we will introduce now the software composition analysis in the static analysis. So Paddy, right now, our pipeline is ready. We have the build, we have the test, and now we are going to introduce that software composition analysis, or SCA. What is that?
Let's dive into that. Software composition analysis, also known as dependency scanning, is all about finding vulnerabilities within dependencies of your code. So it is about finding vulnerabilities in libraries that you use or in other code that you use. When it comes to GitHub, there are two sides to this. One is we can use GitHub platform features, and two, we can add a software composition analysis tool to the pipeline so that we can scan project dependencies directly and under our own control. It usually provides value to use both of them because this may find additional vulnerabilities that you can't detect with one or the other approach. Especially when it comes to the platform features, which kind of provides a new analysis in regular intervals, even when you do not change the code.
So Paddy, why is it important to scan our dependencies and the libraries? Why should we do that? Because are we not only interested in our code?
Well, using other stuff like libraries or other code means that we incorporate this information into our application. And if we use a library with a vulnerability, this means also that our own code may have a vulnerability too now, because we use that other library. Therefore, it is essential to look for vulnerabilities in dependencies or in third parties we introduce into our application. And because sometimes over time people find new vulnerabilities in existing libraries, it's valuable to scan and check also from time to time again. Let's first look at how we can introduce a SCA tool into our own pipeline. We install it like this. We add a workflow using and executing an SCA tool. In our example, we choose CRDA, so Code Ready Dependency Analytics from Red Hat. Note that there is no GitHub standard tool that performs this. So we had to find a tool in the Actions marketplace. We add the workflow to the CI pipeline, so basically to the main workflow file, and we will have to add a security token to authenticate with Sneak. Sneak is a professional security tool that is used by CRDA. And then we need to enable also advanced security, which we do going to Settings, Code Security and Analysis. Having done all this, this is what we get. The tool will scan all our dependencies in our own project and search for known vulnerabilities in public directories. It uses the security tool Sneak to accomplish most of this. And then it creates a standard findings file whose content can be viewed directly in GitHub. GitHub then allows us to list all the findings by risk and by tool that found the finding. To manage the vulnerabilities, you can navigate to security and then code scanning.
There is also a second way which we can go, and this is by using platform features which GitHub provides us. This platform feature is Dependabot. Dependabot will scan through your repository and search for vulnerabilities in your dependencies, and he will do that on a regular basis. You can set up Dependabot by going to the settings, code security analysis, enable there the dependency graph, and then also Dependabot. There you then can enable that you get alerts about dependency vulnerabilities. You also can enable that you get security updates, so Dependabot will then generate you some pull requests and also version updates. When you have done these settings, then as said, Dependabot will scan through your repository for the dependencies, and he will do that in the background independently of your commits. You can also then have a look at the dependency graph where you see all of the dependencies, and due to the setting of alerting, he will alert you about new vulnerabilities which were found in your dependencies. And the real cool thing is that Dependabot also offers you directly pull requests which fix your vulnerabilities in the dependencies. Okay, now we are back in our code, and to enable Dependabot, we will go to settings. In settings, we will go down here to code security analysis. And here, as we saw it in the slides, we will go to dependency graph and enable that. And then we go further down and we see Dependabot. And what we would like to have is we want to have these Dependabot alerts. Therefore, we are going to enable also this. Next, we also want to enable Dependabot security updates so that we get the pull requests for the security updates. So we are also going to enable that. The last thing which we see is Dependabot version updates. And here, Dependabot will open pull requests when there is a new version of a dependency. Now, here, we could enable that, but when you enable that, then for every minor upgrade of a dependency, you will get a pull request. So this is something which you can enable, but we will not enable it in our project. So now we head back up here. So now we can go to Insights and to the dependency graph. And here we can already see dependencies that Dependabot has identified. We see here the POM XML, where we can see that we have a dependency to Maven Surefire, Spring Boot, and what is really cool, you also see the dependencies which we have to the GitHub actions. So now we go back up here. So now we are going to security, and here we can see vulnerability alerts with Dependabot. If Dependabot finds vulnerabilities, these vulnerabilities will be listed here. So also, after waiting quite some time, there are still no Dependabot alerts in here. And when I go back to the code and to our POM XML, then we have introduced here explicitly some version of Spring Boot which has vulnerabilities. So, Padi, why does Dependabot not find these vulnerabilities?
That's actually something we didn't figure out until now. But let us use now sca.yml within the pipeline and see whether we get better results. So let's go and enable code scanning for our repository. It's in Settings, Code Security and Analysis. Then we go down to GitHub Advanced Security. This feature for private repositories needs payment. I enable it. And checking, we see that it's enabled by now, and we set up code scanning, which is done by now. Now one option you have is clicking on Configure Scanning Tool and choose a tool from the marketplace and click on Configure here. But we will show you how to do it manually and understand the code that comes from that. I had to code, workflows, and to our main pipeline. Next, I use a very cool feature that provides me a development environment within the browser. I can start it by pressing the dot key. So let's add the next step in our pipeline. It will be an SCA step. What we do here is we basically tell it to use the definition file we will create soon after in the sca.yml file, and we will inherit again all the secrets to this workflow.
Hey Padi, what is that needs build over there?
Good question. Well, to perform the software composition analysis, we first need to build the application, which is what we tell it here. So we tell it before you can start the SCA job, the build job above needs to be finished. Now I create my sca.yml file, and again I give it a name, 20 SCA, so that it's in the right order afterwards, and I define that it can be started by either manually starting the workflow or it can be called by another workflow, in our case the main pipeline. Next, I add the job description. Don't freak out, we will explain. First, we define the job SCA. Next, we define its strategy. In this case, we decided to go for fail fast false, which means that we want the whole result of the analysis together, not just fail when we find the first problem. We also define that it should run on different operating systems, we defined above here, and that we per default run bash scripts. We give the whole thing a name again, which would be SCA Java project, and then we go through the steps that make up this whole workflow. The steps include checking out everything from the repository and installing Java as we saw before. Then we install the SCA tool, which is CRDA in our case from Red Hat, and we run the scan with the Red Hat Actions CRDA version 1.2 action. And at the very end, we make sure that whatever is presented to us by the CRDA tool is made available to the user interface of GitHub. Note that the CRDA tool requires a secret called sneak key. So we need an account with sneak. and we will create that now. And we also need a GitHub token for the OpenShift tools installer. This GitHub token allows the OpenShift tools installer, so the CRDA tool, to make back calls to GitHub. So basically, this is a token of our GitHub project, which is available by default. So let's commit these two changes and then create our secrets. I add SCA and I commit these two changes. So I'll go back to my project and then to settings. Now scrolling down to secrets and actions. Here I will add a new repository secret. So I give the secret a name and I would add the secret here. I will do that without kind of showing you that. So I've added our sneak key here to the repository secret as so on. Now let me show you how to get this sneak key. For this, we open a new tab in the browser and add app.sneak.io, and there you can create an account if you need one, or you can log in, which brings you to something like this screen here we have. Now let's go to your name and then account settings. And here you can click on click to show and copy whatever you see there and paste it into our sneak secret we defined before. Going back here to our GitHub interface. So let's head back to the pipeline and see what happens. We had our main pipeline run with the already known build step, and now we also have a job that executes the SCA. Looking through the log file, main step being the scan obviously, we see that we actually did find some vulnerabilities as the log tells us. And we also see that this log then was also uploaded to GitHub.
So Padi, it looks like this was quite easy, but between we run now the pipeline and we showed you the pipeline, there was 1 hour between that. What happened, Padi?
Strange thing happened. Looks like, first of all, the CRDA tool is not very reliable. So sometimes we got connection timeouts. Then we had the issue that the sneak key was just valid for 2 or 3 scans, and afterwards login was no longer possible.
So Padi, these are quite serious findings, and for me the whole thing looks quite shaky. Would you use that for an enterprise grade project?
As things stand now, no, that's not usable. That doesn't work for enterprises now. What we need to investigate further is whether there is actually an SCA tool out there that can stand up to the test of enterprise.
But nevertheless, Padi, let's have a look at the findings which we have in this SCA tool that we used now.
Sure. So let's see what we got. Going back, we see that in the security tab, we now have a number of findings. I go here to the code scan part of the menu, and we see all the findings of CRDA. As it used Sneak in the background, we have quite many findings which by the way are actual real findings. I can also sort by tool. In this case, we only have enabled the CRDA tool till now. Also the branch if there are multiple. I can filter by rule or by severity, so I can just view the critical findings. Again, a surprise for us. It's not critical, high, medium, low, but it's categorized as error that we see something. That's not how we used to kind of assess things in the security world. So critical, high, medium would be expected. Here it's called error. We can live with that, I guess, but it's nevertheless strange.
So with that, we are at the end of this video. To summarize what we just did, we wanted to do software composition analysis or dependency scanning. We showed you how we do that in GitHub. We enabled, first of all, the Dependabot, and with that, we got the dependency graph. Then we created our own custom workflow in our build pipeline based on a custom action which you can find on the marketplace. Now, as you could see in the video, the overall experience is not so good on what we saw, and also the runs are quite shaky. Here we would recommend to you that you make in-depth analysis what kind of SCA tool you really want to use and how to configure it so that you have a stable pipeline. With that, see you in the next video, which will be about license compliance.